Okay, we're on to lesson 8.2, apply exponent properties involving quotients. So we're just adding on to what we already know, and we're going to be dealing with quotients, which is division. So before we actually get into the quotient of powers property, let's figure out what it's about. So if we were to do this longhand and extend out a to the fifth over a to the third, it would be a times a times a times a times a. 1, 2, 3, 4, 5 of them. Then we have a times a times a, and that takes care of the a cubed. We know a over a is the same thing as 1, so we can start canceling out all those that match up. Then we're left with a times a over nothing, or 1, which is just a times a, which is also known as a squared. So what did we do here? Well, let's take a look at our original. A to the fifth over a to the third. 5 and 3, how can we get to 2 from 5 and 3? Well, we just subtract them. So that is the quotient of powers property. Basically that you take, if they have the same base, you take the exponents and you subtract them. So this would be the same thing as a to the 5 minus 3. That's a little 3, but I wrote it big. 5 minus 3, and that is a squared. Shorthand, shortcut, just subtract the powers. So if we had something like this, take a look, same base. So that is just 4 to the 10th minus 3, and that is 4 to the 7th power. Saves us the stretching everything out longhand. Shortcut, quick, easy, to the point. You take a look in your book, you can find the quotient of powers property, what it is. Let a be a non-zero real number, and let m and n be positive integers such that m is bigger or greater than n. Basically, how it says, you just subtract exponents if they have the same base, and that will give you the answer. So let's look at, and that all was on page 495. So if you want to refer back to that anytime, you're more than welcome to. Let's take a dive into some of these examples. So quotient of power. So now when we're dividing, we want to subtract exponents. So we have 7 to the 11 minus 10, or 7 to the first power, and we oftentimes just write that as 7. I will accept either answer. They are both correct. Here we have negative 2, and then we have 9 is in the numerator, so we want to subtract that, or subtract the denominator from it, and we're left with negative 2 squared. Okay, moving on. Now we're combining what we did yesterday with what we did today, and we have 4 squared times 4 cubed, all divided by 4 squared. So we know a quick, easy way we could just cross those out. But let's do this using the quotient of powers property as well as the product of powers property. So you can do it one of two ways. You could combine these first and go from there. So we could go 4 to the 2 plus 3 all over 4 squared. That would be 4 to the 5th over 4 to the 2nd, and then we subtract those, and that gives us 4 to the 3rd. Or we could have divided them out to begin with. So if we look back at this, we could have done 4 squared minus, or 2 minus 2 would be 0, which is anything to the 0 power, so 4 to the 0 power equals 1. And so then we're left with 1 times 4 to the 3rd, or just 4 to the 3rd. Two ways of getting the same answer. Now this is just a little awkward of a different setup. So we can combine these to equal 1 expression. So if I put that over 1, we could just multiply straight across. 1 times x to the 10th is 1x to the 10th, or just x to the 10th over x to the 5th. Just trying to be a little tricky, but we know the quotient of powers property. We just take the base and then subtract the exponents, and we're left with x to the 5th. That is the first part of lesson 8.2, using the quotient of powers property. And we're going to take a look in just 1 minute. It'll be on the next video of another property that we will be using.